Question number 22. Workers in a factory commute from their homes to the factory. The table below shows the distances in kilometers covered by the workers. So there is a distance in kilometers, the classes are given there. Then the number of workers are given, that is a frequency. The mean distance covered was 14.5 kilometers. Part A of the question. Determine the value of t and hence the standard deviation of the distances correct to 2 decimal places. So there are two questions here in one. First is determine the value of t, then hence the standard deviation. What are we given? We are given the mean distance. So we're given the mean distance. Now to simplify this and save time, I've created the table that is going to help us what we need in order to calculate the value of t and also to calculate the standard deviation. So I've created this column vertically so that it can be easier for me to solve. So distance is given, the classes are there. Then the number of workers, which is the frequency represented by f, is given there. Midpoint, I'll have to calculate that. Then fx, there's x squared, then fx squared, then there's cf, which means the cumulative frequency, then the totals. So these are the things that I require in order to get the value of t and also to get the standard deviation. How do we get the value of t? To get the value of t, we need to know how to get the mean using the data that we given there. So how do we get the mean? The mean is obtained by, and the mean, which is x bar, is obtained by the summation of fx divided by the summation of f. And that is why, as you look at these, I have to get x. What is x? X is the midpoint of these classes here. Then I need to get that product of f, frequency multiplied by the midpoint, that is fx. Then I get this. So this is what is going to give the mean. And remember that the mean is given as 14.5. So this will help me get the value of t. So how do we get the midpoint? The midpoint is the center or the mid of these classes. So to get the midpoint, that value of x in the first class, 1 to 5, you simply add 1 plus 5, then you divide by 2. So 1 plus 5 is 6, 6 divided by 2 is 3. So the value of x there is 3. The second class, 6 plus 10, you get this is 16, 16 divided by 2, this will get 8. Now you notice, if all the classes are uniform, and I can see that these classes are uniform, the class size is 5. The class size of all these classes, the uniform, they are 5. So that is why you see, look at the value of x, the midpoint. The first one is 3, then the next one is 8. So you see there's a difference of 5. So you just add 5 to get to the other one. So 3 plus 5, you get 8. Then 8 plus 5, the other midpoint of this class will be 13. The other one will be 18. The other one will be 23. And the other one is 28. You see that the value of the midpoint differs by 5 since the class size is 5. So that is how you get the midpoint. Let us now get this product of f multiplied by x. So f multiplied by x, you just take these like f3 times 3, you get 9. Then 6 multiplied by 8, you get 48. Then t multiplied by 13, we get 13t. Then 7 multiplied by 18, so 7 multiplied by 18, you get 126. Then 4 multiplied by 23, 4 multiplied by 23, you get 92. Then 2 multiplied by 28, you get 56. So after getting that, I will also require to get x squared. So the midpoint squared, the value of x squared. So the first one is 3, 3 squared is 9, 8 squared is 64, 13 squared is 169, 18 squared is 324. I think that is 324. If I'm not wrong, yes, it's 324. Then 23 squared, and 529. Then 28 squared, 784. Then from there we need to get the product. This is fx. I want to first fill the whole table, and then I shall go to calculation of t, and thereafter the standard deviation. So the reason why I'm filling some part of this table like fx squared, that will help me in getting the standard deviation. But already what will help me get the mean I've already obtained. But let me just proceed. So fx squared, so get this column for f multiplied by x squared. You need to be very careful. So f, like this, the first one is 3 multiplied by 9, which is 27. The second one is 6 multiplied by 64. 6 multiplied by 64, we get 384. The other one is t multiplied by 169. This will give 169t. Give 169t. And then the other one will be 7 multiplied by, I think I can go on. There's something I was thinking about here. So the other one is 7 multiplied by 324. 7 multiplied by 324 will give 2268. Then 4 multiplied by 529. 4 multiplied by 529, we get 2116. And then the other one is 2 multiplied by 784. 2 multiplied by 784, we give 1568. 1568. Then the cumulative frequency, I must have the value of t to do that, and also you've noted here in this class 11 to 15 I have 169t. So let us first get the value of t. So the mean is given by the mean x bar, which is 14.5, is equals to a summation of fx. So we need to get the summation of fx, that is here, the summation of fx. So we need to add everything here. We need to add everything. 9 plus 48, 9 plus 48 plus 13t plus 126 plus 92 plus 56. So 9 plus 48 plus 126 plus 92 plus 56 plus 13t. This will give 331. 331. Let me not write it there. I can write it later on. So this one will give 331 plus 13t. That is when you add everything there, then divided by the summation of f. The summation of f here, we have this is 3 plus 6, 9. This is 16. 16 plus 6. This will give 22. To give 22 plus t. 22 plus t. 22 plus t, not 6. 22 plus t. So when you add the summation of f, you add 3 plus 6 plus t plus 7 plus 4 plus 2, you get 22 plus t. Now with this expression, now you notice that we can be able to get the value of t by simply you can divide this one by 1 and then you cross multiply. So you get 14.5 multiplied by 22 plus t is equals to I'm cross multiplying, so 331 plus 13t. So opening these, you get 14.5 times 22, you get 319 plus 14.5t is equals to 331 plus 13t. So bringing the like terms together, the t's together, you get 14.5t minus 13t. 5 minus 13, you get 1.5t is equals to, then 319 you can take it to the other side, so 331, p31 minus 319, you get 12. So dividing both sides by 1.5, so you have 12 divided by 1.5, you get the value of t will be 8. So that is how you get the value of t, by simply working out these equations, substituting mean in this formula is equal summation of fx divided by summation of frequency. So t therefore is equals to 8. So now we can insert that value of t here comfortably. So we just need to note that that one is 8. And if that is 8, there's something that we need to now rectify here. 169t will be 169 times 8 because we already have the value of t. So this one, 169 times t would be 169 multiplied by 8. That would be 1352. So this one would be 1352. So you need to correct that. 1352. Then t, I have indicated there, t is equals to 8. That one will also help us to get the summation. So when you get the total frequency now, 3 plus 6 plus t, which is 8, plus 7 plus 4 plus 2, you notice that one will give 30. And then the summation of also we can rectify these. We can substitute these. 13t will be 13 times 8. So 13 times 8, which will be 104. So this will be 104 as well. So 104. So now we can add everything here. The summation of fx. Let us start with summation of fx. So 9 plus. So 9 plus. Of course, we have it here, so it is easier to use this one. Summation of fx is here. 331 plus. So 331 plus. We got it here in this formula. So plus 13t. Plus 13t, and then t is 8. So that will be 435. So this one will be 435 when you add that. Then summation of fx squared, let us add 27 plus, we are adding this column, 27 plus 384 plus 1352 plus 2268 plus 2116 plus 1568 give 7715. So this will give 7715, the sum. Then we can get the cumulative frequency. How do we get the cumulative frequency? We just start from the first frequency, which is 3. Then we keep adding. So the other one will be 3 plus 6, we get 9. Then 9 plus 8, we get 17. 17 plus 7, we get 24. 24 plus 4, we get 28. 28 plus 2, we get 30. So that is how we get the cumulative frequency. So from the first one, you just go adding cumulatively. So 3, then 3 plus 6, 9, 9 plus 8, 17, 17 plus 4, 24, 24 plus 4, 28, and 28 plus 2 is equals to 30. Now, after getting that, now we can get the standard deviation. And to get the standard deviation, I'll have to use this part here. We have to use this part that is here. So the standard deviation is given by the square root of the variance, and in this formula, looking at what we have, to get the standard deviation, we get it by the summation of fx squared divided by the summation of f minus the summation of fx divided by the summation of f. Then everything should be squared. We get the square root. So that is the formula which you're supposed to use, and that is why I had to use all these columns that you can see here. When you look at all these columns, fx, then fx squared, and so on. So we already have all these values, so you just need to substitute in order to get the standard deviation. So this one is equals to summation of fx squared. The summation of fx squared, you just go to the table here. Go to the table, it will be 7715 divided by summation of f is 30. Then the summation of fx, I think for fx we have that fx will be 435. So that one will be 435 divided by 30, and then you have to square that and get the square root. So this one will give 7715 divided by 7715 divided by 30. 7715 divided by 30 will give 257.2. Then subtract 435 divided by 30, which will be 14.5. 14.5 squared, 14.5 squared, we get 210.2, 210.3. Then you get the square root of that. So let me subtract these. 257.2 subtract 210.3, we get 46.9. So you get 46.9, and when you get the square root of 46.9, we get 6.85. 6.85. Let me rub these. 6.85. So if you write this one to correct to 4 significant figures, you get 6.848. 6.848. 6.848. So that is the standard deviation. Now, after getting the standard deviation, I think now we are done with the first part. We find the value of t, which is 8, then the standard deviation. Let's go to the second part of the question. Calculate correct to 2 decimal places the interquartile range of the distances. Now the question here is, how do we get the interquartile range? Interquartile range is given by Q3 minus Q1, where Q3 is the upper quartile, then Q1 is the lower quartile. So this is the most important thing. Q3 minus Q1, that is the interquartile range, then Q3 upper quartile. How do we get these? To get the upper quartile, we just need to take Q3. To get the class where we find the upper quartile, we just need to divide n, 3/4 multiplied by n, and then Q1 is a quarter of the total frequency, which will be 1/4 over n. This will give us the class. So when you take 3/4 multiplied by 30, this one will give us the position. So this will be 22.5. 22.5. That is the position, and then the quarter of these, this one Q1, the position will be 7.5 position. Now we need to identify where will this Q3 be, which class is it. So the 22nd.5, this 22nd.5 position. So this is what you do. To get Q3, we just go to the cumulative frequency. Where do we have 22.5? Where does it lie, in which class? 22.5 lies here, where we have 24. Look at where in the cumulative frequency table where we have 24, 22.5 is there. So the class there is 16 to 20. 16 to 20. So the class here is 16 to 20. So that is the class. Then what about 7.5? The class on the quarter class 7.5. 7.5 will be here where we have 9. It will be here inside here. So that one will fall in this class 6 to 10. So it will fall here 6 to 10. It will fall there 6 to 10. So after getting that, now to get Q3, we simply use that formula that we use to calculate the median of the group data. So to get Q3, for instance, we start with Q3. We get the lower class limit of that class, then multiply by 3/4 n minus CF divided by frequency, then multiply by I, which is the class size. So let me just go step by step explaining what we mean by these. So L is the lower class limit of that class that we found Q3 lies, and when you look at the class 16 to 20, the lower class limit will be 15.5. You just take 16, subtract 0.5, so it will be 15.5 plus 3/n. You've already calculated that, and that one is giving us 22.5. Then CF is the cumulative frequency above that class. Cumulative frequency above that class is so the class is here 16 to 20, and so 16 to 20, so the cumulative frequency that is above that is 17. So the cumulative frequency is 17. Then the frequency of that class, is let's go straight, is 7. So that will only be 7. Then I is the class size. The class size is 5. So these would be very helpful to give us a Q3. So 15.5 plus, so this one would be 22.5 minus 17, be 5.5, divided by 7, multiply by 5, and this one will give, so 15.5 plus we have 5.5 will be 5.5 divided by 7, then everything multiplied by 5, so that will give 19.43. 19.43. So this is a Q3. So now after getting Q3, now let us get Q1. So Q1 is going to be given by L plus 1 over 4n minus CF, everything divided by frequency, then multiply by I. So in this case, I want you to look at the class. The class that we have here is Q1 class is 6 to 10. So the lower class limit will be, so since the class is 6 to 10, the lower class limit will be 5.5. 5.5, because just take 6, subtract 0.5, then plus a quarter n, which you got, which is 7.5, minus CF, cumulative frequency above that class. So the class is 6 to 10. I want you to look at it there. 6 to 10. So the cumulative frequency is 3, and then the frequency is 6. The frequency of that class is 6. Then the cumulative frequency above that class is 3. So let me put these here. So the cumulative frequency is 3. Then the class size is 6. Then everything multiplied by 5. So working out these, you get 5.5 plus this one 7.5 minus 3, you get 4.5 divided by 6 multiplied by 5. And working out this one using a calculator, this is what you get. So 5.5 plus we have 4.5 divided by 6, everything multiplied by 5, so give 9.25. so you get 9.25. so now we have Q3. So we have Q3 was 19.43. so Q3, so interquartile range is Q3 minus Q1. So this one is Q3 was already 19.43, then Q1 is 9.25. so when you get this difference, so 19.43 subtract 9.25, so this one you get 10.18. so that is the interquartile range, and that is simply how you're supposed to solve that question.